Hello, and welcome to another exciting episode of Introduction to Applied AI. I am your host and your professor, Dr. John Baugh. So for this lecture, we're going to be discussing LangChain Part 2, Agents and ReAct Tool Use. So we'll do a little bit of an example at the end. This is a shorter lecture than some of the theory-heavy lectures, of course. I'll provide additional materials as needed to those taking my actual classes, but we are still working out of the LangChain tutorial book that I wrote, little short book, starting out with LangChain. We are specifically focused on tutorials 7 and 8. All right, so we'll look at that. But let's start with agents and ReAct tool use. So where we are so far. So prompts we have explored quite extensively, and we know that they are reusable components, and chains connect prompts, models, and parsers. Memory allows multi-turn interaction. Tools introduce external actions, and the agents decide what happens next. So from chains moving on or moving into agents, a chain follows a fixed execution path. An agent evaluates the situation dynamically. So agents can choose whether to act, choose which tool to use, and respond based on tool results. This is a shift in control flow. So what is an agent? An agent is not magic. It consists basically of a loop, and that loop includes reasoning, decision-making, action, and observation. Everything remains inspectable and debuggable. So what is this ReAct thing that we hear about a lot? Now, this is not, of course, talking about the ReAct library that is provided for web development. This is a completely different concept here. This is reasoning and acting. So it is a prompting strategy. Okay, so ReAct is a prompting strategy. It's not a specific library. It's not a specific framework or anything like that. It just structures how the model thinks and how it acts. So standard ReAct format goes like this. You have thought, action, observation, and then final answer. Okay, so thought would include why the model is doing something. Action is which tool to use. The observation would be the result of the tool, and the final answer is the grounded response. This structure, when using this prompting strategy, enables the reliable tool use that we will see. So why does ReAct matter? It encourages step-by-step reasoning. It separates thinking from execution, makes tool calls explicit, and improves debugging and transparency. It also reduces silent hallucinations. So who actually executes the tools? Well, the model doesn't run the tools itself. The model suggests actions, and your code parses the suggested action, validates it, and then executes the tool. This keeps humans and systems in control. So how do we structure the agent logic? As the systems grow, agent logic becomes harder to manage. Mixing reasoning, parsing, and execution creates confusion. A structured agent design helps by separating responsibilities, right? That's a big topic within software engineering and any area of engineering, really, but software engineering in particular is the separation of concerns. So you're taking the responsibilities and you're separating it to the appropriate agents. It reduces duplication, and it makes behavior easier to reason about. This all mirrors good software engineering practice. So separating concerns in agent systems. So agent systems typically separate the reasoning and the prompting, tool selection, tool execution, and result handling. Each responsibility can evolve independently. This makes the agent behavior easier to debug, easier to extend, and easier to test. So this is kind of a very high-level design and prompt level, or rather agent level, systems level, separation of concerns or modularity, right? So we're basically turning it into these modules, different levels of modules, different types of modules. And that makes it easier to do all of those things. Multiple agents with different roles, so not all agents should behave the same. So different agents may specialize in certain tasks, have access to different tools, and follow different reasoning rules. So this enables clearer, more predictable behavior. Routing and orchestration. So when multiple agents exist, a coordinator is needed. So an orchestrator receives user input, decides which agent should handle it, and delegates the execution. So when you hear the term orchestrator, that is talking about the entity, the part of the program that receives the user input, makes the decision about which agent should handle it, and then delegates execution to that agent. Routing can start simple and become more sophisticated over time. And in this context, we're not talking about the exact same thing as like network routing, right? So where we route packets of information across the internet, for example, this is an application layer or higher layer, application implementation or construction layer in the AI where you are sending a task to the appropriate agent. So we are routing that task to the agent based on their skill set. All right. So common agent failure modes include missing or malformed action step, incorrect tool names, incorrect parameter formats, or the model answering without using any tools. So these are expected and educational along the way. They help you refine your prompts and your code. So what you should focus on would be reading model output carefully, verifying ReAct structure, understanding why a tool was chosen, debugging failures instead of ignoring them, and observing how prompts affect behavior. So how does this all fit into the course? So agents are the foundation for LangGraph, which we will look based on LangChain, RAG, okay, or Retrieval Augmented Generative AI Systems, and multi-agent workflows. So everything after this assumes you will understand ReAct, you will understand tool execution, and you will understand the fundamentals of agent routing. So some takeaways before we actually do the tutorial content or look at it are that agents are structured systems that form a loop. ReAct provides predictable behavior, right? Tools connect models to the real world. Good prompts and good architecture matter. We've been talking about that pretty much since the beginning. And the tutorials are more of the lecture. Okay. All right, we can close that for now. I've got the code actually open. We've got information from tutorial 7. The technologies that we're using in tutorial 7, if I bring this over here from the tutorial document that I have, let me zoom it in a little bit. Oh, let's see, maybe there we go. Okay. There we go. Much better. Now, so the goal of tutorial 7 is basically to have you refactor your tool-driven LLM logic from previous tutorials into a reusable agent core class stored in its own file. So then you would use a separate script to define tools and run the agent against user input. That would set the foundation to scalable or for scalable multi-agent systems. So what about the technologies we're using? So we're using modular design principles and we're applying them to this agent system. So this is a software engineering step, not a new LangChain feature or specific AI thing. It's just essential for scaling your framework. So you'll define a standalone agent core class. You'll define tool logic and execute agent core from another script and improve maintainability and testability by separating concerns. Okay, so I've already got the file pre-created, but you have this agent core class that we have here. All right, and the agent core and the agent test runner are the two files that we are using for this particular one. Okay, so this is the test file, and then this is the agent core right here. And you'll notice that it is setting the model, the tools, which is a dictionary, right, and a description, which is a string. So I've got some code in here that's commented out for the tutorial 8 part where we just would go back and modify this, but that would be the only major modification in agent core. But we start with extract action, okay? So the extract action is basically just using a regular old regular expression, okay, which we're calling RE here, which is RE. It's actually part of the library we've imported here, regular expression. So this is regular expression.search, and it takes a regular expression, has an R in front, just like an F string in Python would have an F in front. This has a regular expression. So this whole thing is the regular expression. You're going to have actions, and then followed by the tool name, and then set of parameters inside brackets. Okay. The reason it's got the backslash in front of it is because we actually have physical brackets in there. If you didn't have that, it would mean something like it does here, where we're dealing with white space related stuff in the square brackets right there. So it means something to regular expressions. All right. So basically, that's what the extract action is doing, is just getting the action. The execute tool is validating the tool, that the tool exists in the dictionary, okay, and then determining if it doesn't exist, then we are saying, hey, it's not available, and then lists the available tools, all right? It executes it and then catches any exceptions. That's what the try catch is for. It's basically saying self.tools at tool name and then passing the parameters to it, and this is applying the appropriate tool with the given parameters, okay? It returns a friendly error string rather than crashing, and that's basically what we want to happen, right? So if it fails, it'll just say tool execution failed, and then gives you the error that occurred. The run on the user input, which is down here, you've got the self and then string. Self is obviously, so we know that this is a method of agent core, and then user input string is really the parameter that we are interested in. So what does this function or method do? So it's basically fairly simple. Okay, so it builds the prompt, and it equals the description plus the question based on the user input. Okay, the response is where we call the model. So when you say self.llm.invoke on that prompt and get the content, that is invoking the model and grabbing the content off of it. And then you can print the raw model response, which is what we do there. And you would do something in the program like, it'll say, ask me something, type exit to quit. And then you'll say, what is 25 times 4 plus 1 or something like that in parentheses. And then it would have a thought, an action. It would define what the action is. Oh, it's calculator. So, because that's one of our tools, we're going to provide it. And then make an observation, provide a final answer. This helps the system think more clearly and make sure that it actually follows these steps and doesn't get ahead of itself or have, lack of organization. Okay, so with the agent core, I'm already in a virtual environment, which I created the virtual environment with Python -m venv and then venv. It's in the instructions with the setup. I activated it with this source venv and then activate right there. I executed that already, and I can tell that I'm already in the virtual environment, which has its own set of installations and things because that venv at the top there. Now, you will also have to install the LangChain library and the other associated libraries from the setup if you're doing a separate project from the previous lecture. So just keep that in mind. So you'll have to do a Python installation for that, or pip installation for that. All right, so how are we actually going to run this? Well, we are going to just say Python and then agent testrunner.py and hit enter. And as long as it's, it seems like it's working. It might be a little slower on the first one, but let's say 25 times, and then say 4 plus 1. Okay, I'm actually going to type it out. What is 25 times 4 plus 1? And you give it a little bit of time. We'll look at the agent test runner here. You'll notice in the agent test runner, we have actually provided two tools. We've got calculator, and then we've got facts. Okay, this is really just a stub. This one's just going to ensure that it calls the tool. It's just going to print a string out, right? So the calculator returns an str of the eval called on the expression. This is not a safe thing to do for a software that you're going to release. So just keep that in mind. So you would use other techniques for parsing, but this is just kind of a quick and dirty way to do it. But you'll notice that we have the tools listed. We have a tool list with calculator. That's the string that they would look for, and then it actually calls the function calculator. And then facts is facts, right? And we provide a description. So the agent behavior description, which is ReAct style, we use the triple quotes here so we can make use of white space and put things on new lines. You are a helpful assistant who uses tools, so we give it a persona, essentially. And then available tools, you tell it there's calculator given an expression and facts given a topic. Use the following format: thought, ... action, tool name, and parameters, and then the observation and final answer. So afterwards, we've got this loading of the local llama model that we have installed. So you say llama 3 and give it a temperature. We haven't really talked about that too much, but just do it verbatim at the moment. Create the agent. So we create an instance of our agent core class that I described before, telling it what model we have, what tools we have available. And again, over here in the constructor, the init method, you can see that the tools is a dictionary of strings and callables, and a callable would be something like a function. If you're coming from C# or you probably have dealt with delegates, or if you're coming from a language like C++, you may have used function pointers. They're not very common for the basic course, but this is what we can do with it. It's something that's callable, is what it's saying. Oops. Let's go back to agent test. Okay. And then the description. Okay. So, and then remember we basically said we utilize a loop here. So we've got this loop here and we're asking the user to put in the particular input, and then we call agent.run. Okay. Which is over here. Okay. So this agent calls run on a specific string and goes through and provides a response. So it gives the raw model response, and then eventually we'll print out the tool used as well, just to give more clarity. Okay. All right. So when I asked it down here, what is 25 times 4 plus 1, it gives the raw model response and then the tools used. Okay, so we can tell it is actually calling our calculator, which is great because, we defined the calculator in the agent test runner as one of the things here. We're just doing an str eval, calling eval, which is available to us automatically. And it's doing the ReAct style thought, action, observation, and then final answer. So thought, I need to calculate a complex expression. Action, it's the name of the tool and then the thing that it's supposed to utilize. So it's extracted that. It knows it has to call the calculator on 25 times 4 plus 1. It didn't pick the facts because it knows that the calculator needs the calculator, okay, to do math. And then it gives a final answer of 125. And then it says, hey, the tool I used was calculator with 25 times 4 plus 1. You can also say something like, tell me a fact about octopuses, right? So in this particular case, it's not going to call the math or the calculator. It has a facts, right? So it's basically saying, fun fact about octopuses, it is surprisingly interesting. So that's kind of a dummy response here. But you can see that you want me to tell you something cool about octopuses. It says it's going to call the facts. It has an observation based on the model being pre-trained, and then gives a final answer here, and then tells us a tool use down here. Okay. Do you have a weather tool? Okay. You can ask it things like that. Give it a minute. And then it'll go with facts because it's not a math problem. You would probably want more tools than this, but you will notice that it says, I'm not sure if we have a specific weather tool, but I can try to help with general information. Action, facts, weather. Okay, yes, according to the facts, there are many different types of weather tools available. And then final answer, unfortunately, I don't have a specific weather tool at my disposal, but I can provide general information on various weather-related topics. Okay, pretty cool. So you have the tool functions. They're just plain Python functions mapped by name in the tools dictionary. The regex pattern extracts the tool name and parameters safely from the model's response. Run handles the reasoning, execution, and printing the results. And this structure makes it easy to add new tools, use the agent in different environments like CLI, web apps, whatever, and extend to multiple agents. Next up, we have Tutorial 8. Tutorial 8 is multi-agent routing with orchestration. So the route user questions to the correct specialized agent, math or info, using a simple keyword-based orchestrator. All right. There's different kinds of orchestrators. Some of them are more complex, but you can look for specific keywords, right? So this allows the agents to have different tool sets and behaviors. So about the technologies that will be used, we have multiple agent core instances, one for math, one for facts. The orchestrator decides which one to use based on keywords. Okay, so while this routing is simple, it mirrors the architecture of larger agentic systems, where routing is later powered by classifiers, embeddings, or flow engines like LangGraph. Okay, so I have the code over here. We've got couple things we need to do. So agent core, I do need to modify. So for tutorial 7, I'm going to comment that out, and I'm going to uncomment the definition that we have for tutorial 8 for extract action. Okay, it's been expanded a little bit with if there's matching and it strips some of the content and things. Makes it a little bit cleaner for it to work with. And there right here is the multi-agent runner and the orchestrator. Okay, so here's the orchestrator. This is fairly straightforward, basically, the route. Using keyword orchestration, there's not really any AI used to extract the word. You're basically using fundamental Python. If there's, you take the lowercase and call it lowered is the name of the variable. If any word in lowered for the words in math, calculator, plus, minus, multiply, divide, if it's in any of these things, it'll return math. If it's not, it'll return info. So that's kind of a catch-all. Info is more of a catch-all, like if it couldn't do it with math. But obviously you could have 50, 60, 150, 1,000 tools, that it could look through before it gets to the default. But right here, it's using the default info. And then you run it, you get the agent information, and then print that the orchestrator routed it to a specific agent. Grab the agent information, the agent name, and if it exists, you run it on the user input, and then otherwise say no agent found for the request. Okay, so for this one, what we're going to do, let me see if I can get this to, oh, there it is. Okay. Took me a second to grab that. This one I'm going to actually quit out of the current one. So it exits, or rather exit, not quit, I'm sorry. Okay, so that exited the actual tool, or the actual software. And you'll note that the specific, where is it, multi-agent runner that we have here, okay, this one's fairly full of information here. It's got a lot of prompting going on here. You've got a description for math. You're a specialized math agent. And it says you must use the following tool, use this exact format, and then we have it do kind of the ReAct format. And then we tell it, do not do this, do not do that, etc. And then it says info, description. You're an info agent. You must use the facts, and then respond only with the ReAct format, don't make up names, etc., etc. Okay, so for this one, excuse me, we have Python multi-agent runner. Okay, and then we can ask it questions just like we did before, but we of course have the calculator and info. So info is a little bit, I believe, more interesting now. Let's see what it, multi-agent, there we go. So the info is using AI at this point. So this one's actually using a description. It's going to apply it by giving the model a persona and work with that. Now with the math, we're going to do something like this. We're going to say, what is 2 times 6 plus 4? Okay, and it says it routed it to the math agent, so the orchestrator made the correct decision, and then the math agent responds. Okay, so it calls the calculator with 6 plus 4 times 2, observation of 22, so then it says final answer is 22. Okay, now, so that's 2. Looks like it's ignoring the parentheses. I'm not sure if, let's see if it actually does this. We may have told it to ignore the parentheses, but let's see here. Okay, what is 2 times, let's do it without spaces. Let's see what happens. 2 times 6 plus 4, because that should be 20. But I think what it's doing is it's just, it's got it. Okay, so it's something about I think parentheses and spacing threw it off, but it's things like that you have to tweak, right? So, did I put parentheses? Yeah, I did before. I think it just forgot the parentheses. All right, so the next thing you might want to do is ask it information about something. So give it a topic. So, or can you tell me you want to do research on machine learning. So what is the softmax activation function is? Okay, so it goes to info agent and it tries to look up information about that, and it'll say, okay, facts, and then the result shows that the softmax, this is it thinking, basically, it's making an observation. So now the final answer, our tool just says, here's a fun fact about activation functions, but the final answer is softmax activation function is a mathematical function used in machine learning and neural networks that takes an input vector and normalizes it into a probability distribution where all values are between 0 and 1, and the sum of all values is equal to 1. Okay? So what's really going on here is this thing is actually realizing that the facts is not giving a sufficient solution, so it's utilizing its own model knowledge, okay, which typically you don't, even if you tell it not to do that, it could be just doing it to spite you. I mean, in spite of you telling it, do not say anything outside of the ReAct format, do not, make up new tool names, you could tell it, let's see, only use the tool, don't rely on your model knowledge or anything external, and we could see what it does if I have that. I'm going to quit the model here. Oops, exit, sorry. All right, let's see here. Exit. Okay, now let's try it again. And we're going to do it. This time we're going to say, tell me about softmax activation. Okay, so it routes to info, and we will see what happens. Okay, so it is still trying to get around it. So we're not really enforcing it. So this is showing that the model is trying to cheat. Okay, so basically stubs are not always adequate. This also gives us an example of why retrieval augmented generation exists, why enforcement matters, etc. So you could do a two-pass over it, or you could do, we could try different variations on this. So I could say, furthermore, I could put, you must not provide any factual content not present in the tool output. Okay, so we'll leave that and then try it again. And then say, tell me about softmax. Okay, we'll go to info. It may or may not work. We'll see how this actually functions. Okay, so yeah, so it's still trying to get around that. But there's some other things we could do here. Like you could actually make it so that it doesn't have the thought, the observation, or the the final answer of with anything other than the action. Okay, so you could remove some of this and modify and play around with a little bit more to try to see if you can get the prompt to do what you want to do. So that would be kind of a cool exercise. But anyway, this should give you at least a basic idea of how these systems work. So we do see it is calling the tool. It's just what it would finally provide to you might not be what you expect. So you do have to add some enforcement and do validation and retry. That would be what you would do for like production. And then you could just put the action, don't do an observation, don't do a thought, etc., etc. And you could also, once you get into like retrieval augmented generation, you're able to control that a little bit better. So, all right, so this is, again, just to give you a little taste of some of the stuff that LangChain can do. It's very, very powerful, but we see that it does try to cheat sometimes when it doesn't get what it considers a satisfactory answer. It really doesn't like being wrong, so you want to definitely, work on the prompts and try to refine them and see if you can get them to do exactly what you want. That would be a good little thing that you could play with. There are also 2 additional tutorials in the lecture that you could look over, or in the book rather. So this one, let me see here if I can get it. I'll go up to the table of contents. Okay, so the tutorial 9 adds the doc search tool. And then you can also use tutorial 10, enhanced tool handling and error feedback. But I do think that this at least provides some of the foundational tools that are really, really good for what we'll need for LangGraph, which I think will get probably some better results than what we're maybe just getting with LangChain. But this is a simple application of it. We're not really putting any enforcement in and things like that. So it's what we expect, honestly. All right, so that's what I've got for you for this lecture. And I hope that was helpful and useful and insightful, where you can see some of the success and failures going on with this and see where it could be improved beyond the tutorial. And I would encourage you going through the other additional tutorials as well. All right, that's what I have for you, and I will see you in the next lecture. Bye-bye.